All right, today we're going to learn about solving quadratic equations using square roots. All right, and what we can see is that this is a square root symbol, okay? There's no number in the kickstand, so it's understood to be a 2, so that it can undo a square, which is a 2 exponent. So that's our square root symbol. Now, the first one we're going to tackle is x squared equals 9. All right, now, whenever you have a square, and that means you have a quadratic equation. So that means if that's the highest power in your equation, then that means you have a quadratic. If it's just like y equals x plus 1, the power on x is 1, so it's a linear equation. It's not quadratic. So as soon as you get this power of 2 is the highest power quadratic equation. So you could factor, you can use quadratic formula, things like that to solve, but sometimes it's easier to look at this and see if you can do it by square roots. All right, so the only time you're really going to use square roots is if you have the x squared term and just a number term. So you're missing the b term, the middle term with the x. So when that happens, you want the x squared on one side, you want the number on the other side, all right, and usually we put the x squared term on the left side and the number on the right side. It's how we like to solve. And what we have to do now is undo the squaring. A square root will undo the squaring. And if you look on your calculators, you will see that on the x squared button, above it, usually in another color like blue or green or red or yellow, you will see a square root symbol. All right, and that means you'll invoke the second functional level of that, and you'll hit the square root symbol or the x squared button to invoke that square root symbol to undo the squaring. So they're partners. All right, so to start here, we're going to take the square root on both sides. Okay. Now, when we do that, we have to account for the fact that the number that is being substituted for x could have been positive or negative. So we have to put a positive and negative sign in front of the number side only. The x squared and the square root will cancel out, leaving you what's inside or underneath the radical, called the radicand, okay, but drops the x out. This becomes positive or negative square root of 9. All right, now we can take the square root of 9 because it is a perfect square. So we're going to do that, and so x is equal to positive or negative 3. All right, so what we're saying about this is that x is positive 3 or x is negative 3. Okay, so there are two real solutions here. And remember, the real solutions are the x-intercepts of your parabola if you were to graph this. So when you're writing up your final answers, you got x equals positive 3 and you have x equals negative 3. Those are two solutions, and they're real numbers. Okay. Now, as we said prior to this, when we started, you don't know if this was positive or negative for that x before it was squared. So if we test it out, if you substitute 3 in positive 3 squared is 9. If you put in a negative 3, okay, negative 3 squared is 9, okay? And what we mean by that for a check means 3 squared in parentheses, which means 3 times 3, as we've learned. And if we put in the negative 3, it means negative 3 times negative 3, which is 9. So there's a good check, all right? So that's how you know what you're doing here. All right, let's move to the next one. All right, so the next one is x squared equals 16. So if we want to know the answers to this, we're going to take the square roots of both sides because we already have x on one side, numbers on the other. Okay, we have to account for it being both positive and negative before it was squared. And our x answer will be x equals positive or negative 4. So x equals positive 4 and x equals negative 4. And again, we have two real number solutions. All right, moving on. A little bit harder looking, but not really difficult. We have m squared equals 169 over 9. All right, so what we'll do is we'll take the square root of both sides, positive and negative on the number side. M will drop out of this because these will cancel. We have positive and negative, the square root of 169 over 9. Now you can try to divide 169 by 9 and it could be divisible, and that's fine, or you can do this individually, which is what I usually do, because I'm recognizing that 169 is a perfect square, as is the square root of 9. So positive and negative, we can take them apart. We can do this individually. So m is equal to a positive or a negative 13 over 3. All right, and you can use your square root formula, or your square root charts. And if you don't have it, you can look it up on Google. You can get a square root chart, and you will see your square roots. Okay, so those are 2 answers. So if you're going to write these up independently or individually, you would have a positive 13 over 3, and m equals a negative 13 over 3. All right, next, a little tricky. M squared equals negative 25. All right, this is a unique case, so start, unique case, and you have to think about this. Can you square a number, any number, positive or negative, and get a negative result? And the answer is no. So here, this is a no solution, or no real number solution. So it's no real number solution. That's your answer for that. No real number solution. And the reason is you can't take a number and square it and get a negative result. All right, so if you want a little explanation, let's write that down. You cannot square a number and get a negative result. A number, I'm going to abbreviate here, number symbol, and get a negative result, or a negative number. Let's put it that way. All squared numbers come out positive. So right here, you got to recognize that. It's going to be a problem. However, if you put it in your calculator and you took the square root and you went into robot mode, all right, so we're going to write robot mode. And you just said, okay, I have to do m squared equals negative 25. I'm going to take the square root. I'm going to get m equals positive, negative, and negative 20, square root of negative 25. And you put that in the calculator. You're going to get a calculator error. Okay, calculator error. Oh, can't even spell today. Calculator error. Okay, so we're going to have a problem. All right, that tells you that something's wrong, and that what's probably wrong is that you cannot take the square root of a negative number because any number squared is positive. So this would tell you there's a problem. So keep your eyes peeled for that in case you go into robot mode. All right. X squared equals 0. Alrighty, well, we can take the square root of both of those, okay, as we do, positive, negative, drops out as x equals positive, negative, square root of 0. Square root of 0 is 0. We don't need a positive, negative because it's a neutral number, okay, it's neutral. So just x equals 0. Now in this case, we only have one answer, and it's a real number, okay, we don't have any problems with that. So we have one real number solution for this. The only time that happens is when x squared winds up being equal to 0. If x squared equals to a positive number, you can always have 2 solutions. If x squared equals to a negative number, you're going to have no real number solutions. And that becomes imaginary numbers, which we haven't touched. You'll do that somewhere in Algebra 2. All right, next, x squared equals 5. Okay. Again, we're going to start solving. We know that a squared number can equal a positive, so we're good. So we know that we're going to have 2 solutions because it's not equal to 0 and it's not imaginary. It's not a no real number solution. So we start, we take our square roots, positive, negative, just drops. X equals positive, negative, square root of 5. So x equals to a positive square root of 5 and x equals a negative square root of 5. Now this negative is outside the square root symbol, so this is okay. That just means a negative number, all right? But it's a negative square root number. So now what we want to do is take your calculators out, and you want to approximate that to the nearest hundredth, so 2 decimals. So we take square root of 5 on our calculator, and it equals to approximately 2.236. And if we want to go to the 100th place, we're going to approximate it and round appropriately, so it would be 2.24. And we probably should put our squiggly little equal signs for approximately equal to. And on this one, we're going to have x equals to the negative square root of 5, so it's going to be x is approximately equal to negative 2.24. And those are your two answers, this one and this. So you still have two real number solutions, one positive, one negative, but they're going to be in decimal form because 5 is not a perfect square. All right, let's get to a couple more examples. Okay, not too hard. X squared minus 7 equals 9. So we got to get x squared by itself, so we're going to add that 7 to each side. And we're going to get rid of that. We're going to get x squared equals, what is that, 16, right? So we're going to take our square root on each side, okay, because x squared equals a positive number, so we're in good shape. So x equals positive, negative, the square root of 16. So x equals positive 4 and x equals negative 4. Two real number solutions. That's what you got out of this, two real number solutions. Next, x squared plus 14 equals 5. All right, so we need to get x squared by itself, so we're going to bring that 14 to the other side. That goes to 0, so we get x squared equals, now 5 minus 14 is negative 9. Now you look at that, and if you go into robot mode and you take the square roots, you're going to get an error on your calculator. If you use your smarts, you say, can I square a number and get a negative number? No. So no real solutions. These would be imaginary numbers. We know they exist. We don't know what they are right now. You'll learn in Algebra 2, but we know that there is an imaginary number component versus the real numbers that we work in here. All right, and that would be your final answer. All right, next up, 2x squared plus 5 equals 15. Just want to cover all our bases here. Same thing, we want x squared by itself, numbers on the other side. We're missing that x term, so we don't need to put everything on one side and factor. So we can use square roots here. But again, this looks a little bit more complex than we had. So we wind up with 2x squared equals 10. We divide by 2 on each side. X squared equals 5. Now we can take the square root of each side, positive and negative. So x squared is now gone. X equals a positive and negative square root of 5. So up here, x equals positive square root of 5, and x equals negative square root of 5. Those are exact numbers, and their approximations are 2.24, and x equals negative 2.24. And last but not least, we have x squared plus 9 equals 9. We're going to subtract 9 on both sides because we see there's no middle term, no x term. It's just x squared and a number. The numbers on the right, variable on the left. X squared equals 0. Okay, we go through our motions. We take x squared, a square root of that. We get x equals a positive negative square root of 0. Square root of 0 is 0. It's as neutral. There's only one answer, so we just drop the positive and negative and we say it's 0. So in this case, again, one real solution. Okay, now this one above it again, even we got two answers, but even though they're radical answers or square root answers, we still have two real solutions. So just FYI, anytime you get two answers, you have two real solutions. Anytime you get one answer, which is only going to be 0, one real solution. And anytime you get an x squared equals to a negative number, you will have no real number solutions. And that is how you solve using square roots.